Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. Today we are walking the line to understand slope better. Slope is how you describe the rate of change of a graph of a linear equation. So we're taking this off of the coordinate graph, the coordinate plane, the math grid. We're taking this activity, this concept of slope, off the graph paper and into some real life situations.
Today we're going to walk the line. I've chosen 3 objects to represent the negative direction of my walking line, the starting point, the 0 of my walking line, and the positive direction of my walking line. I also have created a map on the coordinate grid to help me plan out how I'm going to walk the line, and then I'm going to walk the line, practice walking the chosen distances in equal time intervals. I've already rolled the dice twice to randomly choose the distance that I'm going to go in the next 10 seconds. So the first roll got me to negative 4 feet in 10 seconds, and then the next roll gave me negative 2 more feet in 10 seconds, and I'm going to do the product. So the product of negative 6 and positive 6 is negative 36. So I'll go 6, 12, 18, 24, 30, 36. I end up at negative 6. So for the next 10 seconds, my distance doesn't change. Now, I could do a bunch of things in between that 10 seconds as I end up here if we were not talking about linear relationships. But since we are, and we're trying to represent what a constant rate of change is, no change is a horizontal line. And that's what I'll do here. So for this 10 seconds, I'm not going to move. Okay, sum. The sum of negative 1 and positive 3 is positive 2. So I'm going positive 2 feet in the next 10 seconds. Okay, sum. Positive 5 and negative 2. Positive 5 minus 2 is 3, so we're going 3 feet in this direction. And then sum. Positive 4 and negative 1. Positive 4 plus negative 1 is positive 3, so 1, 2, 3 for the next 10 seconds. So for the first, it looks like about 54 seconds, I will be to the left of the golf clubs, the little tight golf clubs. Since I'm starting in the negative direction and I don't return to the positive direction until halfway through the 1 minute time, it takes me time to build back up to 0 and then cross over to the positive region. But the rates of change, the steepest, the fastest is going to be at the beginning. I'm going to be traveling 4 feet in 10 seconds. And the slowest will be the 0 because I won't be changing at all. These two are the same. Negative 2/10 and 2/10 are the same speed because their absolute values of their slopes are the same, but the directions are different. Here I'm heading towards the negative, more negative, and here I'm heading towards positive. So let's see what this looks like actually walking it out.
So I'm starting at my 0, which is the Little Tykes Golf Club. And then you can see to the left of the screen that the red plate represents the negative direction, and to the right of your screen, the green plate represents the positive direction. I made my map on a piece of paper deciding what my distance over 10 seconds. I picked equal time intervals, so I picked 6 different distances, and I'm going to see what those 6 different speeds look like. So walking the line, remember the slope of a line tells you the constant rate of change if it's linear. So my rate of change in the first 10 seconds is going to be fastest because I'm moving the most distance in the same amount of time. So here we go. I'm going to use a timer to help me. I have to go 1, 2, 3, 4. I have to go about this distance in 10 seconds. So I'm just going to see that speed really quick. Well, oh well, I'll just try it. And then I'm going to go until I hit the chair, and then I return. I stay there for 10 seconds, and then I go 2 feet in 10 seconds, and then I go 3 feet in 10 seconds, and then I go 2 feet. No, and I go 3 more feet in 10 seconds. Okay, so let's see if I can do this. Maybe I'm going to mark these like times when I change direction. So I have to change directions at this stick. No, not change directions, change speed. And then 0, and then I come back to this stick, and then I go 3 feet. So I'm going to go to this stick, which is only a foot away from 0. And then I go 3 more feet, which takes me to 2 feet past 0. Okay, so I planned it out, and let's see how this goes. Okay, I'm going to press start, and I need to move 4 feet in 10 seconds. Facing the negative direction, and I'm going 4 feet in 10 seconds, 4 feet in 10 seconds, 4 feet in 10 seconds, 8 seconds, and I'm at 4 feet. Now I have to slow half my speed. Half my speed is 2 feet in 10 seconds. 2 feet in 10 seconds. I'm going 2 feet in 10 seconds. And now I need to stay here for 10 seconds. I'm staying at -6 feet for 10 seconds. I'm not moving. Now I need to go 2 feet in 10 seconds. So returning to the speed I just arrived with. Halfway, I'm at 1 foot. And I have made it 2 feet in 10 seconds. Now I need to go 3 feet in 10 seconds. So it's a little bit faster, but not quite as fast as the 4 feet in 10 seconds from the beginning. Okay, now I'm at 3 feet. I'm continuing at this speed. 3 more feet in 10 seconds. Passing 0. Now I'm on the positive direction. Finally, I passed over the 0 stop, and that was 1 minute. So now I also want you guys to think about 5 different sort of, if you look in the PDF enhancement, it talks about sprinting and tiptoeing. Oh, there's a bumblebee. So a sprint, what would that look like? Would that be steep or shallow if I'm sprinting in the negative direction? Or what if I'm sprinting in the positive direction? Sprinting in the positive direction. Or what if you're tiptoeing? Is that going to be shallower or steeper than a sprint? In the whole walk the line activity that I just demonstrated with my graph paper, that was pretty much tiptoeing at different speeds, very subtle changes, versus a sprint and, just a casual walk forwards. Or does the direction you're facing matter? So it's all for you to interpret, and I really encourage you to just think about, okay, this standing is a horizontal line across the XY plane. There's no change in my distance, okay? If I'm heading towards the negative direction, does that mean I'm above or below 0, or does that mean I have a line that's going up from left to right or a line that's going down from left to right? What does that mean? Okay, so it tells you the direction of the steepness of your line. Are you climbing up or are you sliding down? Okay, anyway, so now a sprint in the negative direction, how's that different from a sprint in the positive direction? Versus, is walking backwards towards the negative? What is that? How is that the same or different from walking forwards in the positive direction? Okay. And an undefined slope is, it's sort of like falling rocks or dropping an object. There's no change in its direction from a starting point in relation to the ground. It's moving, for sure. Like this little golf club is definitely moving, but it's not moving left and right, it's moving up and down. And in linear equations, we call that undefined because slope is how much y changes as it changes in the x direction. If it doesn't change in the x direction, we can't compare how much it changed in the y direction to nothing, right? We can't. There is change, but it's not change horizontally, so we call it an undefined slope. I hope that makes sense. I hope I got it right for you guys. Thanks for tuning in. Check out the Muddy Math YouTube channel for more tutorials and help. Feel free to email me for requests, and I'll catch you next time. Now let's take it to the trails. On the hiking trails, I bet you there's ways to think about rate of change that aren't related directly to graphing points on a coordinate graph. So let's see what we find out in nature.